and welcome to our 5-minute tutorial on pressure screens, part of the series of tutorials aimed at the Level 3 Technical Certificate. Cleaning is very important. Cleaning stops damage and wear to equipment, and it also stops bad material going through onto the sheet. As we mentioned in our cleaning tutorial previously, centrifugal cleaners separate contamination by virtue of its density. Pressure screens separate contamination by virtue of their size. So this is a traditional graphic that we show just to get people to remember that. A pressure screen is essentially a sieve, and you pass through the sieve material that's got a mixture of different sizes. The bad material, which is too big and we don't want, we collect on the sieve. The good material that we do want passes through the sieve. So let's just have a look at what a pressure screen consists of. It consists of three main parts. There's the body of the pressure screen, or the housing. So that's this bit here. This is where you've got all the pipes going in and out. So as you can see, we've got the inlet here. We've got the accepts coming out there. We've got the rejects coming out there. We've got some dilution water going on. So we've got the housing. That's the bit you see when you walk past it. The bits that do all the work you can't see. Inside we have the basket. So this is the sieve. This is the thing that actually separates the small good stuff that we do want from the larger bad stuff that we don't want. And finally, there's the rotor, or the hydrofoil. And this is the thing that keeps the surface of the basket clean so that we keep getting good separation. If we look at the way that you can pass stock through a pressure screen, there are actually three different ways. So in this diagram here, what we've got is this solid line here represents the rotor. The dotted line there represents the basket. So you can see the rotor is on the inside of the basket, keeping the inside clean. We're bringing stock in to the middle of the basket and then getting it to pass out through the basket to the outside of the basket. And we're keeping that inside surface clean using the rotor. This is a plan view. Again, the dotted circle represents the basket. The little teardrops represent the hydrofoil. And you've got the perforations there. So we bring stock into the middle and pass it out in the direction of these arrows. And these hydrofoils keep that inside surface clean. The other two ways, we use stock from passing from the outside of the basket to the inside, and then taking the stuff that passes through as the acceptable material. So now we pass stock through the basket from outside to inside, and here we have the hydrofoil, and the hydrofoil is also on that presentation surface. It's keeping that outside surface clean. And again, plan view, perforation there represents the basket. There's the hydrofoil on the outside. As you can see, this time the arrows are pointing in. So we're sending the stock from the outside to the inside. And then finally, another example of the stock going from the outside to the inside, but this time we have the rotor on the inside of the basket. And again, there's the basket, stock is going from the outside to the inside, and the rotor is on the inside of the basket. We'll look in more detail at the baskets and the evolution of the baskets, and then we'll have a look at the rotor. So the very first basket that was invented was called a hold basket. So it had a beautiful, absolutely perfectly smooth surface, almost like a chrome cylinder, and they drilled thousands of holes through. So the idea now is that you've got a hole in a basket and the fibre can pass through the hole. So anything that's much bigger than the diameter of a fibre will be rejected. That will be kept on the outside of the hole and the fibre will pass through. Then they had the idea of, rather than making holes, let's make slots. And that was quite an interesting idea. So now you've got a slot, and the belief is that fibres will now go through this way, through the slot. And that gives us an interesting option, because not only can we use slotted screens to separate out good fibre from bad contamination, we can also use it to separate out long fibre from short fibre. And there's a whole variety. There's another 5-minute tutorial on why we should separate out long fibre from short fibre. That again starts off as a very smooth cylinder, and they drill a hole through, drag it down with a reamer and turn it into a slot. So in both the case of the holes and the slots, this is a cross section. That can either be a hole or a slot. So the idea is that fibres will come through here. But of course, occasionally, fibres will get caught across there, so they get dirty. So you need to try and keep it clean. And that's the job of the hydrofoil. But the people who did this thought, how can we make it self-cleaning? So the third generation, what they did was, they bent in the area just around this perforation, be it a hole or a slot. They bent it in. And now, as stock travels over here, because of this bend, you get turbulence created, and the turbulence becomes a self-cleaning action, and it helps to keep that perforation clear. So generation 1 was holes, generation 2 was slots, generation 3 was profiled holes and slots. In other words, they bent it to create extra turbulence by the water passing over. And then the 4th generation is what we call wedge wire. They realised that rather than having a smooth cylinder, cutting out a slot or drilling a hole and then bending around that particular space, why not just take some wires? As you see here, we've got some sort of keyhole shaped wires. Put all the wires together, weld them onto this device. This thing here becomes then the length of the slot, and the space between the wires becomes the width of the slot. And because you've got a wire, you've automatically got a contour to the slot or hole that to the slot that you've produced, and therefore you don't need to do that as a separate action. So 4 generations of baskets: holes, slots, contoured, wedge wire. So that's the device that separates out what we want from what we don't want. How do we keep it clean? We keep it clean with the rotor or a hydrofoil. And as you can see here, 2 typical designs of hydrofoil. This one looks very strong and solid and robust. And that's the sort of hydrofoil you would use in the thick stock area. This one here, different design of hydrofoil. This looks a lot more fragile. It's much harder for one of these things to break off than it is one of these things to break off. So you would use this sort of hydrofoil in an area where you wouldn't get as much buffeting around. So this is the sort of rotor that you would use in a low consistency area. What do rotors do? This diagram really explains the action of the rotor. So there we've got the basket. This is the body of the rotor. There's that particular hydrofoil. As it swings around, the front of that hydrofoil is pushing the water, the stock, producing a positive pressure pulse. And this there is dragging along the back of the surface. This is almost like an outgoing nip. So this is producing suction. The belief is that the positive pulse developed at the beginning of the hydrofoil will push anything that's got stuck in the perforation, it will push it out to clear it. Anything here that's on the surface, this suction will suck it off. So positive pressure pulses push things through the perforation, negative pressure pulse sucks things off the surface. And why do we clean? We clean using pressure screens for exactly the same reasons we clean using hydrofoils. It prevents wear and damage to equipment, it prevents wear and damage to pipes, and it prevents contamination reaching the sheet. So just to summarise everything that we've said, screens separate by size. There are 3 ways of setting up flow in a hydrofoil. We've got stock going to the inside, coming out with the foil on the inside, and we have 2 cases where stock goes from the outside to the inside, one with a hydrofoil on the outside, one with a hydrofoil on the inside. The evolution of baskets, we started off with holes, then we went to slots, then we profiled the holes and slots, and finally we went to wedge wire. The rotors produce 2 pressure pulses, a positive pressure pulse that pushes stuff through the perforation, and a negative pressure pulse which keeps the surface clean. And rotors, if you remember that initial diagram, we had a single rotor, and now the rotor is broken up into lots of little bits. And the reason for that is to minimise pulsing. Every time that hydrofoil goes past the pipe exit, it's pushing stock through. So if we only had 2 rotors and it pushed through every half turn, we would get lots of pulsing that would then lead to barring on the wire. So they've broken up the rotors into lots of little rotors so that we don't get the same single pulse, we get lots of tiny little pulses, and so we eliminate the barring action. Cleaning reduces wear, damage and contamination. Okay, thank you for listening to this tutorial. You can find us on all the social media.